Hey Laramie Middle School. Just another quick video to help you work through the modeling that I'm asking you to do with the possible causes of temperature change assignment. So I've kind of pre-drawn some of the things that are asked of you in the assignment. This is supposed to be in your science notebook. You are there. The assignment asks you to label across the top modeling interactions between the cup system and energy, but the name of the assignment in Canvas is possible causes of temperature change. And then on one side of your page, you are supposed to label a cup system and light, and on the other side, a cup system and heat or cold. So I've kind of pre-drawn some of the cups also just to kind of make this video shorter. So we're going to start by focusing on the cup system and light model. And the idea is looking at your cup, and in our cup we're going to have cold water, so I might label draw my water in my cup and label it cold water. Okay. If I had lots of time, I might shade it in to make it look like it's actually, 350 milliliters of water. And then over here, you can see our light. I just have the silver light there, but maybe I'll draw a light bulb in it to show where the light is coming from. Now, you could draw other sources of light, right? Perhaps the sun, or a different kind of lamp, or a heat lamp, whatever you feel inspired. So the question is, as this light shines out of our lamp, it hits our cup, and how is that causing a temperature change, and how can we illustrate what's going on? So these are just your ideas. You're not expected to be an expert on this yet. So as this ray of light hits our cup, now this is a clear cup, some of that light is going to transmit through the wall of the cup, right? And we'll have other rays that are going to transmit through the wall of the cup. Now some of these rays may partially reflect back off, and if you wanted to illustrate that, you can also do that. But as they partially reflect off, they're also going to partially transmit through the cup wall. And of course, as they hit that cup wall, there is going to be a little bit of absorption of the energy into the cup wall. So there I've illustrated the light hitting our cup. Now we could zoom in on it and think about how that is affecting the molecules of light at that point, or sorry, the molecules of matter. Sorry, light does not have molecules. So we're going to zoom in right here with one of our zoom in microscope eyes. We've got the wall of the cup. I'm going to label that cup wall. We've got cold water inside, so if we're zooming in, right, we are looking at water molecules here that are filling up this space because they're liquid, right? Liquids fill up space. They're not very organized like a solid. Okay. If we wanted to think about our cup wall is a solid, right? It is highly organized and bonded. Can you see that when I'm drawing? I don't think you can. Okay. Very organized cup wall made out of solid molecules bonded together. What do we have outside our cup wall? We have gases, right? Gases are also molecules, and so they're kind of, random, and usually we'll just kind of illustrate them like this. We won't get too much into matter at this point. So as our ray of light enters towards the system, it hits this cup wall, and it's going to transmit its energy into the molecules along that cup wall, right? Which are then going to transfer from one to the next, from one molecule to the next, moving from from hotter materials to colder materials, right? And so it's going to transmit molecule by molecule through the cup wall, and then it's going to touch the water molecules and warm them up, okay, which are going to circulate around and warm up all the molecules that they touch until everything reaches equilibrium. Okay, so there's the cup system and light. Now let's think about our cup system and heat or cold and what that might look like. Put that stuff over. This one I set off to the side so that we would have room because we don't have to draw the light. But let's start again with water. We've got cold water. So I'm going to illustrate heat in this drawing. You could choose to illustrate cold. But if I have cold water in my cup, right, filling up my cup, 350 milliliters, sitting on the counter, and it's a hot day in our classroom, right? So we've got, maybe we'll just call it warm because it's really not as hot as like a hot day, say, in Central America. So we've got warm air circulating around out here, right? Warm air circulating through the room. Okay, and as it touches our cold water cup, it is transmitting energy into the system. Turn off my phone. Okay, so let's zoom in and talk about what that might look like. So we'll make a zoom in circle here. What does it look like? Here's our cup wall. We'll label it cup wall. Okay. Again, the cup is made out of plastic, which is a solid. Solid particles are organized and bonded together. They vibrate, but they don't move or change form. So I'll get my cup wall. Molecules all drawn here. Okay, is that good enough? You get the idea, right? The cup wall is made out of solid molecules. Inside the cup, we have a liquid molecules of water. Now, they are attracted to one another, but they're not bonded to one another because they're liquid right now. And they fill up the bottom of their container. I should draw bigger circles, take up more space. Do you get the idea? This is our water molecules. Water. Maybe I shouldn't do cursive. Molecules. Okay. And then outside of our container, we have warm air. So maybe we'll illustrate those with and air again is a generic non-scientific term for gas. So we have gas molecules, and they're usually, depending on what they are, two atoms bonded together, and they're zooming around, right? And as a water molecule, or sorry, as a gas molecule collides with our cup wall, it's going to transfer its energy into the surface that it touches, because these are warm gas molecules. And remember, thermal energy transfers from the warmer substance to the cooler substance. So it's going to transfer its energy into the wall of the cup, and those solid energy is going to transfer through the cup. It's going to radiate across. Well, radiate's not the right word. It's going to conduct across. And then as it gets across into the liquid, it will start to transfer to those colder liquid molecules. And you can see how it would spread there. All right, so modeling interactions between a cup system and light and or heat and cold. So good luck.